we can expect ETL. ETL is nothing but extract, transformation as well as loading. What does the operational database over here consist of? So it consists of ERP, then CRM informations as well as banking systems. So middle tier is none other than our data warehouse, where there is a server which holds the ETL. Hello everyone, I welcome you all to the first session that's under Unit 2. Yes, we have completed Unit 1 and we are stepping towards Unit 2. That's under Fundamentals of Data Science. Over here, my name is Deepa Kutnikar. I'm working as an assistant professor under Department of Computer Science, Vidhyaashram, Temple of Excellence, MYSURU. Unit 2 under Fundamentals of Data Science is all about understanding data warehouse. Yeah, exactly. As we have understood basic knowledge of data science, now it is a way for updating ourselves by understanding the data warehouse in depth. So let's move forward and see the agenda of today's session. In today's session, we will be discussing the basics of data warehouse. Then we will be understanding different definitions that's for data warehouse, and we will also see the father of data warehouse. Yes, absolutely. There is a person who has introduced or invented this data warehouse technique. Who is that person? So we'll be learning all these things in today's session. After that, we will also learn the data warehouse architecture, that is nothing but three-tier architecture of data warehouse. Then we also will be discussing various characteristics as well as multi-dimensional data models. Then we will discuss various schema orientations as well as different types, and we will also discuss the OLAP operations. So this is the agenda of today's session. Let me tell you, data warehouse is one of the lengthiest unit because we are dealing with multiple things in this unit. All right. So this is the agenda. Now let's move forward and understand the introduction of data warehouse. As we know, data warehouse is something like there will be a system server and various supporting systems which will support that server system, right? In the same way, data warehouse is just a collection of subject-oriented and we can say time-variant as well as the non-volatile collection of data sets. When we understand like what is it, now we have to understand like why it is used. Yes, it is being used or utilized to store some statistical data, or we can also say we can store the historical data too. Then let's move forward and understand what is the use of storing these information or the data. Yes, it is used for business intelligence as well as in almost all of the decision making techniques. So we will make a decision by seeing previous cases, present cases and all, right? Yeah. Over there comes a relation where we will be comparing the data with previous historical data and all. So that's why it is being used or it is being supported to make decision as well as the business intelligence. All right, now let's move forward and understand the definition of data warehouse. Also, there is a person, as I repeated, there is a person who is called as a father of data warehouse. He is none other than Mr. Inmon, who is called as a father of data warehouse. And with respect to him, he has defined the data warehouse. And it's a time to see and understand like what is the definition of data warehouse with respect to Mr. Inmon. Yes, he defines a data warehouse as a subject-oriented, integrated as well as time variant and non-volatile collection of data that supports the management decisions. So this is a complete definition with respect to Inmon, and now there comes one more person who has updated this warehouse technique, and he is none other than Ralph Kimball. And with respect to him, the data warehouse is also defined as a collection of data marts organized in a business process. Yes, Mr. Ralph also did defined the data warehouse, and according to him, this is the definition. Now, over here, we have a simple diagram in order to understand the data warehouse technique. So, initially, we will be having multiple operational systems, correct? The operational systems, we can observe here there are multiple operational systems. From this multiple operational system as well as different set of files, what happens is all the information are extracted as well as it is been transformed to the next stage. But in case any of the operation is in process, then it will be showing a status of loading. So the first process is with respect to operational system, where we can expect ETL. ETL is nothing but extract, transformation as well as loading. Once this ETL process is done, then the information is sent with respect to data warehouse. So for this data warehouse, now we have updated term which is called as metadata, correct, right? The metabase, we will always see or relate our information with the metadatabases, right? So metadatabase is a data warehouse server, all right? So all this information is being sent to data warehouse, which is nothing but a metadata, or we can also call them as a summary data followed by a raw data. All right. Now the information is stored here. What's next? Next, what happens is either a OLAP analysis will be done, or we can expect a data mining. So information will be either sent to data mining or it is been sent to OLAP operations. Then after sending the information for both of this, any of the information is been pending, then it is been reported. So this is a complete cycle where you can easily understand the process of data warehouse and the technical term of data warehouse, which is none other than metadata, or they'll also call it as a summarized data or a raw data. Now, one more important thing to remember here is a father of data warehouse. Great. So this is a complete definition process of data warehouse. Now let's move forward and understand the three-tier architecture of data warehouse. Now let's understand this three-tier architecture, but before that we have to remember like what is the use of making the architecture or dividing the architecture into three tiers. The first and most important point to remember here is this data warehouse will support the businesses to make the informed decisions. So how is this informed decisions taken? It is taken depending on the large data sets which is stored in a data warehouse. Now, as it is stored in the data warehouse, it becomes crucial to understand like what is the architecture of this data sets, right? So now it's time to understand the three-tier architecture. The three-tier architecture, it provides a clear structure of data processing. So how is this possible is we can divide the architecture into three different parts, and through this we can expect there is a complete easy extraction of information as well as management. So that's why the three-tier architecture is very important. And let me tell you, this is most important question from unit 2 with respect to your exam as well as internals point of view. Now, as it is a three-tier, it is been divided as bottom tier, next one is middle tier, and the last tier is called as top tier. Now, the bottom tier, it will consist of a complete data sources like the data from OLAP or the data from the extraction, which is also called as external data. Moving forward, the next tier is none other than a middle tier. So middle tier is none other than our data warehouse, where there is a server which holds the ETL. So this diagram we have already seen, which includes of ETL. ETL is nothing but, what is it? Do you remember that? It is none other than extraction, transformation as well as loading. So there will be data from this process, then there will be information from either OLAP engine. So we can expect these two things under this middle tier. Next is a top tier where it is also called as front end tools and which holds the reports, dashboards as well as the data minings. All right. So this is a basic review of the three-tier architecture. Now let's move forward and understand each tier in depth. Starting with a bottom tier. As we know, under bottom tier, the thing which exists is the data from different data sources as well as OLAP analysis, or we can also accept data from external sources. All right. So this is a simple figure where the bottom tier, which will be consisting of total data sources. Now, how the data sources are manipulated or formed is there will be a data from either operational databases or from other sources. So this forms a complete bottom tier. So this is very, very important. You have to draw this figure in order to explain the bottom tier. Now let's move forward and understand what does the operational database over here consist of. So it consists of ERP, then CRM informations as well as banking systems. Followed by this forms a complete legacy system. Why is it? Because each will holds the data from various systems, right? Also, it will be holding information from the web sources where all the web data as well as market feeds will also be there, or we can also expect that under this. Followed by what is the goal of this bottom tier architecture? The main goal is ETL tools extractions, then to clean, transform as well as load the data. Apart from ETL analysis, if the data falls under loading, then again that data has to be called, it has to be cleaned, extracted, it has to be transformed as well as it has to be loaded back to the next stage. So this is a main intention of this first tier, which is none other than a bottom tier architecture. Great, let's move forward. So next tier is none other than middle tier, and it is nothing but a data warehouse, correct? So now let's see a simple architectural diagram here which shows middle tier architecture. So under middle tier, we can expect the information that is extract, clean, transform, load as well as refresh. So this is a thing. Next, there is a next thing which is a metadata. So this is very crucial part. Also a data warehouse, as we can see, this forms a complete central part. And for this data house, how the information is stored? That's by using this data marts, the small data marts. And further, what is the thing? Then we have to monitor and integrate. Like monitoring is which are the data we have sent, and integrating like multiple data, that's from one from transformation, one from metadata, one from data mart. All the data has to be integrated and it has to be sent to the next part. So all these things will be monitored here. Later on, what happens? It is fed to the new server and we can expect it has a OLAP engine. Great. Now moving with the theory part of this. As we know, this runs the OLAP engine. Yes, the information from complete extraction, cleaning, then from metadata and also from the data warehouse, the information is fed to the next stage, which is called as OLAP engine, right? So this will run that OLAP engine, followed by the middle tier includes the data warehouse database, then the metadata repository as well as various data marts. What are those various data marts? So altogether, this part is called as data storage, followed by the OLAP engine. Great. Now let's see the goal of this middle tier. The main goal of this middle tier is to process the queries and aggregate the information. Along with that, if there is a scenario of storing some information of the data, yes, even it can be done under this tier. So we can see here this forms a crucial set under three tiers. So that is none other than our middle tier architecture. Up next, let's move forward and let's understand the top tier, or which is also called as the front end architecture. With respect to top tier, now let's see what is a top tier architecture and what are the things which are supported under this top tier. Under top tier, the things which has been included are data analysis, then the query as well as various reporting tools can be designed by this architecture, followed by data mining. So all these are the various applications that are supported. So if we consider any one of example like the reporting time or the query generating, the main tool that is being utilized in this generation, it is none other than Power BI as well as Tableau. So you might have heard this. So these tools are also supported by this front-end application of data warehouse. Then later, if we want to design any dashboards with respect to our organizations, yes, it is possible by this. Then followed by if there is any query analysis or any query things which has to be raised. So it is possible with respect to this front end. Also, with respect to data mining, yes, it is possible as well as supported by this front end. All right, now let's move forward with the top tier architecture. Under top tier architecture, the main thing to note here is it is completely front end driven. Now, in order to design the front end, what are the different things that we can do by using this data mining or by using this architecture and all? So let's see one by one. By using this data mining, we can design various query as well as reporting tools. For example, Power BI as well as Tableau. So these are very essential as well as very advanced tool that we are utilizing in the various organizations in today's era, because they support each and everything with AI and even with respect to the basic things too. So it is a combination of both the things which the organizations are considering it, using it with a very good response. Great. Up next thing that is been supported is if you want to design your own organizational dashboard, yes, it is possible. Then later, if you want to mine some data, yes, even that's possible. And now let's see what is the main goal of this top tier architecture is it helps managers to take the data driven decisions. Usually you might have observed the top management always they have to take multiple decisions. Now for that multiple decisions, always they can't take the decisions based on various criterias, correct? There will be something which is called as data. So it will be very helpful for them. By seeing that data, they can easily take the decisions like, okay, these are the things, these are the data. By comparing these both, they can easily decide like what is correct and what has to be decided at the end. So all this thing is possible by this front end design, and we can see a simple architectural diagram over here for front end, where this front end or top tier supports in analysis as well as data mining, then in query generating as well as reporting, etc. So this is a front end tool that can be expected. Up next, let's move forward and see a complete three-tier architecture together. So this is a three-tier architecture where it starts with a bottom tier, which is also called as data sources, followed by the middle tier, which is completely utilized for data storage. And over here, you can see there is a data warehouse, which has been supported by metadata as well as different data marts. Great, right? Then further, after these two, we have the main crucial thing, that is a top tier, which is also called as front-end applicational design. And under this, various tools that are formed or that can be designed are based on analysis, that is data analysis, or either data query system followed by any reporting things or data dashboards that has to be designed. Yes, all the things are possible by using this architecture. Now, by seeing this, we can say that Yes, this is a complete clear architecture, and also we can easily extract the information, isn't it? Yeah. So this is all about the three-tier architecture. It is very easy and simple, and you can easily gain marks if you just explain and draw this diagram. All right. So this is with respect to the architectural part, followed by the next thing is it is multi-dimensional model. Now, here comes a various representation of information. So in order to represent it, what is required? Some pictorial representation format is required. So the first thing that we have considered is a cube format. So the information is being represented in a form of a cube. So when we consider a cube, we can easily say that our information is being represented in a 3D form. Correct, right? There is a x direction, there is a y direction, as well as a z direction. So in all the three directions, the information can be splitted and the required information can be extracted in a very clear form. There will be no confusions like, oh my god, this information is from this source or what it is. Nothing will be there. You can clearly pick or extract the information that is required. Now, in order to do that, there will be a need of some dimension, correct? Now, how is that dimension coined? It is basically dependent on various perspective of the data. If we want to draw a graph, then we can easily consider a time. Then if we won't need time, then we can go with product for any organizational information, similarly region. Now, how is it measured? It is measured by the numeric values, where various numeric values such as sales information, then a quantity information, as well as profit or loss information, or all of them can be depicted in a cube form. Now, as you can see here, it is been represented the product, time, as well as a location. So in this type, the information can be represented in a very easy format, and it is called as multi-dimensional data model. Now let's see and understand like what are schemas for multi-dimensional data representation. Now, as we speak with multi-dimensional data, we know basic multi-dimensional data has been represented by using a simple cube where the information can be extracted easily. But if you consider a recent trend and a data warehouse, all the stuff, then there is a complete integration of multiple information, right? So, which gives rise to a complex set of data. Now, we have to see that complex set of data and we have to work with that. It might be online or offline. Both the things must be possible, correct? So, for that, what happens is if we go ahead and design few schemas. Schemas is none other than representations of our multidimensional data other than cube formats. If we go with that format, then it might be helpful for representing the complex informations. This forms a foundational path for data warehouse as well as for online analytical processing approach. And what it helps for? It helps for business intelligence. So for business things, it becomes very, very easy and helpful. Now, as we saw like why schema and what is the difference between a simple representation as well as a schema. Now, let's move forward and understand like what are the different types of schemas. Yes, there are various types. Starting with a star schema, then we have a snowflake schema as well as a fast constellation, which is also called as a galaxy schema. So these are the three various representations. Now let's see like what are those and how does it forms. So the first one is a star schema. As the name itself says, it will be in a star format. And this is a most basic and widely used representation format. Through this, we can observe here is a fact table and various dimension tables. So these dimension tables are formed by using this fact table. And whenever some information is required to be extracted, then you can directly denormalize this dimension table. Instead of going to fact table again and again, you can directly denormalize this dimension table and extract the required information. So that's the thing. and we can see here the representation is completely in a star format only. So this is a star schema. Up next, let's move forward and understand the second schema or the second type of representation of multidimensional data, that is none other than our snowflake schema. This type of schema is utilized for a bit complex type of information where there will be multiple tables or images will be there. A snowflake schema is a multidimensional database representation format. So over here we can observe the main fact table. Fact table is there and multiple dimensional tables are formed. And we can observe here, this is a fact table and various dimension tables. Now, it resembles a snowflake. It is called as a snowflake schema. All right, let's move forward and understand the next type of schema, that is a fact constellation, which is also called as a galaxy schema. So this is a representation of a galaxy schema where the fact table will form a dimensional tables, but the main thing to note over here is the fact table will allow a common dimensional tables. Okay, so that is very important. So we can observe here we have various fact tables, that is two fact tables, and it will form the common dimensional tables. Great. Now we can observe the representation is in a galaxy form, so it is termed as a galaxy schema or fact constellation schema. Also, we can say the fact tables are interlinked with each other. So this is a complete galaxy format of schema representation, or we can say it has a multi-dimensional data representation in a form of a galaxy schema. All right, let's move forward with OLAP. OLAP is none other than online analytical processing. So OLAP. OLAP, it is a technology which enables fast as well as interactive analysis of multidimensional data, which is stored in a data warehouse, and it supports the decisions. Now let's see what are the different key features of this OLAP. The first one is the multi-dimensional view of data, or the data cube representation is possible. The next key feature is the fast query performance. If any query is raised, then it will be answered in a very quick way. Next one, it supports complex analytical aspects or analytical queries too. Then the main use of this is it is used for trend analysis as well as for reporting purpose too. The final thing what we can do over here, one more thing, is it is for read intensive as well as historical database information can be gathered from the data warehouse. So this OLAP forms a complete new technology which completely supports for a fast as well as interactive analysis, which is easily used for making quick decisions. All right, let's move forward and let's see simple applications of OLAP. The OLAP applications includes sales as well as marketing analysis, followed by financial reporting as well as forecasting. Then if we consider any companies, then it is used for inventory as well as supply chain analysis, followed by for business, it is used for business intelligence as well as decision support. So these are few of applications that is supported by OLAP. Moving forward, now let's see what are the key OLAP operations. As we understood, like OLAP is very important thing, and then there are many multiple applications which is used in real-time analysis and all. So it becomes crucial to understand the key operations, like which are the operations that supports in making that key decisions or in making that applications possible. So the first one is roll up. So this is a prominent as well as basic operational type. What happens here is we will be there with some hierarchy, and that hierarchy is being moved up in order to create a summary of the data or the information. So you can observe here this is a roll up cube, and from here information will be moved up in order to summarize the complete information. Next type is a drill down. So over here we can see, so this is a drill down operation, and here what happens is it provides complete information or detailed data by moving down the hierarchy. Thus it is called as drill down. The next type is a slice. So this is a slice format where, as the name itself says, each block is extracted and it is taken forward to make a decision. So this is three of the key OLAP operations, where first one is roll up, where the decisions is made by moving up the hierarchy in order to make or give a summarized data or the information. The next one is a drill down, and under this drill down, what happens is the detailed information will be provided by moving down the hierarchy. Up the hierarchy is roll up, down the hierarchy is drill down. Next, third one is slice. Here, particular block is being considered in order to understand and check the feasibilities. Next types of operations are dice. Here we can observe the dice which selects the multiple dimensional values to create a smaller cubes. Next one is a pivot or rotate. So this is a pivot or rotate. As the name itself says, it reorients the data to view from different directions. Next one, it is a drill across, which supports the analysis of data or the information from multiple fact tables. Next one is drill through, wherein the accesses detailed data from underlying operational databases. So these are the various OLAP operations that is considered. This was today's session, and in the upcoming session we will be discussing the data cleaning as well as data integration part. Till then, thank you.